Alright, this is the lecture for Chapter 8. Chapter 8 is all about editing. Editing is a more important function in GIS than what a lot of people realize, because at some point in time you're going to start to make something, create something, build something new from scratch. Or you're looking at like an aerial photo and you're trying to delineate a boundary of a parcel or a building or something like that, and you have to go in and create polygons, or you want to trace a road or put in where a new road could be. And as you do these things, you'll realize that if you haven't done editing in a while, which is often the case, you'll have forgotten how. So you'll do your tutorials obviously on this chapter, but I really want you to take the time and work through the exercises as well, just to help you. Now, if it has you to do like the same repetitive task like 38 times, do it a few times until you're comfortable and move on. So like if you have to digitize a geology layer, whether it's in the tutorial or in the exercises after the tutorials, you don't have to digitize every single piece of geology. Just do a few, get the hang of it using the different tools that they want you to use, and then move on. I don't want you to spend so much time just doing the repetition of applying it. Alright, there's only about 30 couple slides in this, so I'll go through this and then make the video, and I'll talk to you guys tonight at the beginning of class a little bit, and we'll get you moving along on your projects. Editing refers to updating existing feature classes or creating new ones. That's the two flavors, if you will. It's either fixing or modifying something or making something brand new. This could be new features, spatial features, attributes, moving around nodes and intersections to fix or to change. There's lots of things it can mean. Almost all editing does eventually, if you think about it, revolve around the idea of topology. Topology refers to the spatial relationship between features. Ideal relationships match those in the real world. When we do that, it's called achieving logical consistency. Logical consistency simply means that things in the GIS behave and interact the same way they do in the real world. Okay? If it's an overpass, it's an overpass. If it's an intersection, it's an intersection. If it's an underpass, it's an underpass. It's not simply two lines crossing and not knowing whether it's an intersection, overpass, or underpass. Topology is the set of rules that guide how these spatial features interact, and they make it so you don't have things, or you shouldn't have things like dangles, that if that, an example at the top, if that node doesn't reach over to that line, then there should be a gap there. And if there isn't a gap there, it's the way it's supposed to be, like at the bottom. It also prevents things like gaps and overlaps in examples where you have two polygons that have a single common border, but they don't have a single common border. In this example, you can see how these two polygons, the lines on the left at the bottom, they don't line up. Okay? If you have topology rules in place, that is something called a coincident border or boundary, and it basically means that one line between those two polygons has to be the same for each polygon. It's one line that serves two polygons. Now, we can force that and we can fix that. The hardest thing to do is to draw that. Okay? And one of the things that you'll learn in some of the editing techniques is not to try to draw over top of other lines, build out from and onto, and use things like the cut tools and things like that to split things apart. When you try to draw on top of a line like that, you're never going to get it right, and you're going to have gaps and overlaps, or slivers at the minimum, and it's all going to create problems for you. One of the ways that we prevent these problems is the use of snapping. Snapping is basically a resource built into the software so that if it thinks you're trying to click on something and you click, it just automatically takes that point that you just clicked and puts it to that thing that it thinks you're trying to put it on. And so we do this a couple of different ways. For example, it can be a linear distance on the real world. So if you get within 100 meters of something in real space, regardless of what that looks like on the map, and you click, it's just going to automatically pull you over to that node or that line or what have you. And so it looks for these vertices in polygons and lines, and it tries to pull them over to where they're at. Now the example here they show where you're clicking outside of that radius is your snapping tolerance. Line B, you click inside that, it automatically snaps it over to the end terminus of line A. Line C, you're outside the radius, it leaves it alone. And this brings up the real rub about snapping. If you set the tolerance too big, everything that you click is going to go to the nearest whatever. And if you set it too low, it's really not that much help because you're not going to get that close. Now, like I said, you can set it at real distances or pixel distance on the screen. So there's different types of snapping: end snapping, edge snapping, and vertex snapping. End snapping takes it to the end of the line. Edge snapping takes it straight into the line itself, and vertex snapping takes it to the nearest vertices within the area. And there's a more formal written explanation of what I'm saying. Coincident polygon boundaries. Polygons are stored as complete loops, and that can create problems because you have loop A and loop B. We'll call it the green and the orange. And while they're complete loops, where they come together there, that should only be one line. And so that loop should be identical. It should be coincident. So how do we make it do that? Well, it's all about how you edit it when you draw it, really, because otherwise you're going to have that. And so that creates problems, and that's one of the things that we use the topology for. We can also set rules that inhibit things like gaps and overlaps. So what are the types of some types of changes that can happen? And we also want to talk about file locks. File locks are important. I'll get to that in a second. Schema changes are those that affect the structure of a table, such as adding, deleting fields, or modifying domains. Remember, schema is that sort of big overarching idea of what everything's supposed to be. Editing changes affect the properties of individual features, coordinates, or attributes. Both type of changes will place a file lock on a feature class until the changes are saved. What does that mean? All right. If you're making changes to a schema or editing something, either one, you're adding fields, modifying domains, editing features, moving stuff around, you have to do this stuff typically inside of an edit session, and until you save those changes you made, that file cannot be used anywhere else. So say you make these changes and then you want to take that layer and you do something with it in your map document, you can't. You can't until you save it. Editing is not possible when there are unsaved schema changes and vice versa. You have to make your changes. Once you decide that they're what you want, save them. If you're unable to create a new field, then there are unsaved edits to the data set. That's just one of the ways it works. So the rule of thumb, the practice you should engage in is make a change, evaluate the change. Is the change what you want? Yes, save it. No, back up and fix it. Coordinate systems. Maps can have different coordinate systems from the data that they're in. For the data, from the data in them. If the map and the coordinate system are different, editing coordinates will be converted on the fly and stored in the data coordinate system. On the fly is wonderful and horrible at the same time. It makes things display properly. It doesn't change anything. And so you can have data that's in different stuff. It'll all be displayed the same. If you edit the coordinates, it'll store the edits, but it will then automatically correct and display the way your map is. So basic editing tips. Always have a backup copy of your data just in case. Alright? So you're going to edit something. Step number one, make a copy. Edit the copy. If everything works out great and it's good when you're done, great. Then you can delete the original or keep it or whatever you want to do, but you have the things that you need. If you edits are permanent changes, and so that if you screw something up, if you know exactly how, there's always the possibility you could unscrew it up, but it's much more likely that if you screw something up, you won't know exactly how you did it, and you'll just have it, jacked up. In which case, you'll have to go back and find your data again. But if you make a backup copy, you have two options then. Save the backup copy as a resource somewhere, or edit the one that edit the copy and keep the original. It doesn't matter which way you do it or how you want to think about it. The bottom line is keep a copy that is what I like to call unfooled around with, and then one that you've been working on. Save your edits often, and here's why. You make a change, it's good, save it. Make another change, it's good, save it. Make another change, it's good, save it. Make another change, oh crap, I messed up. What do? Stop, close it up, stop the edit session, don't save your changes. It reverts back to the last time you saved the changes, which was the last change you knew you did right, and then pick up where you left off. That's the basic idea of how I do it. Creating a feature class. This is something that people forget all the time. They want to draw a line or make a box or do something, and the moment they go, it's like, excuse me, it's like I turn on the editing tool and I bring up the toolbar and I can't get it to make anything and nothing's working and what is wrong? Before you can edit something, you have to create it. And so you have to go into your catalog pane or use the create feature class tool, in which case you'll name it, you'll place it, you'll decide what type it is, you'll select the coordinate system, all that kind of stuff, and what you're making is a blank feature class. So it'll create exactly what you ask for, it just won't have anything in it. But once it's made, you can then edit it, and you can draw in the lines, the boxes, the points, the polygons that go with it. The edit ribbon up at the top is basically where all your tools are at. It has a bunch of them. They're grouped primarily on the edit ribbon, clipboard group, manage edits group, excuse me, the snapping group, features group, and the selection group. And each of these basically have different functions for what they do. You can see them listed here. I'm not going to read through the list for you. You can do that on your own. But pretty much everything that you need is going to be right up there. In the contents pane, there's also several things that are really useful when editing. View by selection allows you to see just the things you selected. View by editing to enable or disable editing for each layer. That can be useful. So if there's some layers you want to edit but others you don't, you can simply deselect the ones you don't want to mess with so that you don't have to worry about inadvertently working on the wrong one. View by snapping enables or disables snapping for each layer and controls what layers have the highest snapping priority. So maybe you want to snap to a certain thing when you're making your edits. This would allow you to do that. So you might snap to a different layer while you're editing another layer, but you don't want to mess up the other layer, so you turn the editing off on, say, layer number 2, but you set your snapping on for layer number 2, and then you're editing layer number 1, so that whenever you get to the point where you want to click or whatever, if you're within the distance, it'll automatically pull it to that point on layer number 1. The create features pane, it is a tool in itself that allows you to go in and do this. It contains templates for a lot of different things, and it's the basic tool that you use to begin to create a feature. Feature templates quickly access the construction tools and the attributes for a layer. It can have multiple templates, lots of different setups for that. Working through the tutorials and the exercises and prices books, she'll run you through a gamut of these. And again, it's great experience to see all the different things that you can do. No one really expects you to remember them all. Modifying features is another thing that we do pretty often. The Modify Features pane contains a lot of the tools that allow you to work on an existing feature. And these are things like moving, scaling, rotating, aligning, reshaping, redigitizing, modifying sections, moving vertices around. Lots of things you can do to uh, change the shape, location, and accuracy of a feature. Attribute pane is its own sort of tool for editing stuff. It allows you to go in, click on edit features. Um, a little different than the way it was in ArcGIS Desktop. I think you guys will like this better in the end once you get used to it. Arranging the edit panes. Once you're in the attributes, you see at the bottom you've got that pane for editing, and you see down there where it says attributes, modify features, create features. Simply by clicking those bottom tabs, you can jump around back and forth to whichever one you need. Sketches are provisional features that we use when we create or modify shapes. The vertices and segments between them are shown, and so the construction toolbar is used to modify, create corners or curves, trace things, finish features, or even cancel it and say, I didn't like this. Editing context menus. There are several helpful menus that can be accessed by different actions or screen clicks. General editing, sketch menu, dynamic constraints, vertex menu, all have their own little place in terms of what they help you do or modify when editing. And again, Price will run you through all the stuff that you need to know. We'll look at the general editing context menu. It appears when the select button is active and the user right clicks the map. It does a variety of useful things. You can copy or delete features. You can explore your map, manage sections, move, scale, and rotate features, edit vertices, and even open up the attributes pane. The sketch context menu has the tools used to construct segments or vertices with constraints such as a specific XY or perpendicular or parallel to another feature, making things at a specific length or direction. It appears when a sketch is active and the user right clicks away from the sketch. Dynamic constraints. The bottom of the map view has a dynamic constraints button. When toggled on, it shows the direction and distance for the next segment at all times instead of just when a sketch tool is selected. Dynamic constraints are helpful when entering survey data. The vertex context menu contains tools that allow you to edit vertices of a sketch. You can add them and delete them. You can move them. It appears when a sketch is active and the user right clicks on the sketch. So you right click on the star and other things pop up. Right click on the vertices to delete it. Right click on a segment to add a vertices to it. Pretty straightforward. The snapping toolbar helps maintain correct topology when digitizing, editing. Turn snapping on and off and set the type of snapping that you're looking for. Remember I mentioned earlier there was multiple types. You can set your tolerances as such, and a pop-up button below the map provides even quicker access to these functions and allows you to use them. So how do we create adjacent polygons? Draw the polygon and then add a new polygon with the autocomplete polygon tool. In this example, you click inside the one polygon and then you click to the first place outside, finish drawing it until ultimately you click back inside, and when you do, it cuts off those dangly bits that go inside the first polygon and just gives you the second. This is one of those things that allow you to create polygons with coinciding boundaries without having to deal with gaps and overlaps. You can create additional adjacent polygons using the same tool and doing things like that. When you see there at example C, it doesn't work. The reason it doesn't work is because those polygons that you're trying to cut across aren't adjoined, and so it doesn't complete a loop. Once you complete a loop, it will then complete the loop. There's also a tool called splitting polygons where you start outside, draw your line all the way through, and then it's basically like doing sort of an intersect or a clip kind of a function to where it just creates that new line segment and takes the one polygon and makes it into two, and then you can cut it again and again how many different times you need till you make it whatever it is you want. We talked a little bit about topology and logical consistency and making sure things are maintained, those interactions, when we modify stuff. Map topology is a means of doing this without having formal topologic rules in place from the get-go. If a polygon feature is edited and it creates a gap, the adjacent polygon doesn't change. Okay, so you change that inside polygon, you just create a hole. A map topology enables adjacent or connected features to be edited simultaneously. So basically what this is if you build your stuff correctly so that it has intact topology, and you activate or utilize map topology, when you modify one feature and that feature has a coinciding boundary with another feature, it edits the other feature so that the two lines move as one. Now if you're actually trying to create that gap, then you want to turn your map topology off. Editing edges, it tracks the adjacent polygon, the shared boundary, it calls it an edge. Many modified tools have edges tabs that use the map topology. By switching to the edges tab and modifying the edge, the correct topology is maintained. Editing nodes with topology. Lines connect to each other at nodes. So you got one line crosses another line, where they cross, it's a node. Map topology tracks connected lines. If the edge tab of a modified tool is used, the line remains connected when the node is moved. In other words, you got an intersection, it's a node, you pull it down to where it's supposed to be, and guess what it does? Drags it right down, lines it right up. The stretch geometry proportional option moves the line smoothly instead of creating abrupt changes, and so you can set it to do it really, really rough or really, really smooth. Annotation is a set of labels stored in a feature class with attributes for its font, size, style, and so on. Each label can be edited individually, and the annotation can be generated automatically. And this is something we use to create things called dynamic labels, or that we construct one at a time. Annotation can be used in many maps and projects. And so the idea with annotation is you got labels for a data set. There's limited things you can do as far as labels, but if you can convert those labels into annotation, it's essentially a label that acts like a point. Now you can change the status and the font and all that kind of stuff and move individually around where you want those things to be so they're not stuck as much. And that allows you to put multiple names in places where you can see things, and this works good when you have data that really gets bunched up. Annotation is given a reference scale so that it maintains a consistent placement relative to the map feature. At the reference scale, the labels appear at the assigned size. When you zoom out, it reduces the size of the labels. When you zoom in, it makes them bigger. Creating annotation, there's a tool. Start by creating dynamic labels. So you go from labels on to dynamic labels, and then you convert them into annotation. And that's pretty much how it works. There's a create features tool that will allow you to go in and create annotations, obviously.